how much money will she have at the end of every month starting from second month onwards. Find a linear expression to represent the amount she will have in the nth month. The last video we talked about linear relationship, how we find it out. Okay, I gave an example of squares and we did it. So we will continue that with this question. Now here the solution. Let's start the solution. The student has the initial amount is rupees 500. Okay, every month she gets monthly pocket money. Monthly pocket money. Now monthly pocket money is rupees 150. That is, she gets every month 150 rupees. Okay, now we have to find out what money she will have at the end of every month starting from second month. So after 1 month she will have 500 plus 150, that is rupees 650. This is at the end of first month. Then after second month she will have this rupees 650 plus another 150, so which is rupees 800. Okay, we can express this as she got initial amount was 500 plus monthly is 150 rupees, and for second month we are counting, so this is 2, so this makes it again 800. So this is what is important part, how you should think the question. You could have got the answer in this way also, but since we have to develop a linear relationship here, so we will appreciate this approach. Now again, according to this approach, after third month, what is her amount going to be? Initial amount is rupees 500 plus monthly she gets 150 rupees, and since this is third month I'll multiply it by 3, so this gives me rupees 500 plus 450, and that makes it rupees 950. So at the end of third month she will have 950 rupees in her pocket. Okay, now further he says find a linear expression to represent the amount she will have in nth month. By now it is very clear that if it is second month we multiply this by 2, and if it is third month we multiply it by 3, and remaining expression is same. Okay, so on that line we can easily conclude that the required linear expression is money at the end, that is money at nth month is 500 plus 150 n. So if I denote this by another symbol, say m is 500 plus 150 n, where n is the number of month. where M is money at the end of nth month and N is the number of months, then this is our required linear relation in this case. This question is very, very important and it develops how we should think and observe. See, this result we have just got by observation. Okay, let's just consider another question, okay, of the same type. The question is, a rally starts with 120 members. Each hour, 9 members drop out of it. How many members will be remaining after 1, 2, 3, and so on hours? So we have to develop a relation according to this given information. Solution. Rally starts with how many people? As given with 120 members, right? Each hour drop is 9 members, means 9 members are walking out of the rally every hour. So at the end of first hour, you will have 120 minus 9. Got it? So this gives you 111 members are left. And then at the end of second hour, it will be 120 minus 9 into 2, right? This was the first hour. This is the second hour. We have to just understand this step. Okay, so this will become 120 minus 18, which is 102. So now 102 members are left in the rally. Similarly, if we move ahead at the end of third hour, it will be 120 minus 9 times 3, third hour, right? So this will be 120 minus 9 3 are 27. This is only 93 members will be left. Okay, by now you might have got the idea how we can write the required linear expression. So required linear expression is members left is given by 120 minus 9 into n, or if we can symbolically represent this as m is equal to 120 minus 9n, where m is number of members left, and n is r, right? So this is again our required linear relation. Okay, guys, this is very important questions, and here a thought process is needed. You have to think. Fine. And this times your 9th class syllabus, most of the questions require application. This is application. Okay, let's quickly take another question of this type. Suppose the length of a rectangular box is 7 centimeter and its breadth, it's not height, its breadth is 11, right? So let us start the solution. Simultaneously we will understand the question. Now length of the rectangular box is 7 centimeter and its breadth is 11 centimeter. We can imagine a box also. Say this is a rectangular box. Fine. This is its length. This is its breadth 11 centimeter and the length is 7 centimeter. And let's assume the height be h. Then you know the formula for volume. Volume of cuboid is length into breadth into height. Here we are given length 7, breadth 11 and height. So we have the volume as 77h, right? Now further what he says if the height is 5, so volume when height is 5 centimeter is V equals to 77 into 5. Okay, and volume when height is, second part, it's 9, so put 9 centimeter and you will have volume equals to 77 times 9. Okay, we are stressing only on the expression, we can solve it out also, that's not a big issue. Now volume when height is 13 centimeter will be 77 into 30, right? So by this we come to know that every time this part is varying, so this is a variable, so the required linear expression in this case we can put it as V equals to 77h, right, where h is varying constantly. Okay, so this is the required linear expression in this case to represent the volume of a rectangular box. Hope by these three examples the concept is clear. Do try few more questions from your book, and in case you come across any difficulty, do DM me. And also if you haven't applied, you haven't subscribed the channel, do subscribe it, also share it with your friends. Thank you very much. Bye bye for now. In the next session we will meet again with another new concept from the same chapter.